A pleasant day, everyone. I am John Calbongato. Together with me are my group mates, Camille Deloria and Rain Abadilla. And together we are the Group 3. Today we are going to present to you Agsala, a filtration experiment on the water supply of the vicinity of Cabantian district. So first up, our environmental problem. So what is the problem that we are trying to solve here? Unsafe water supplies have a significant adverse effect on people's lives due to the factors such as water pollution, a never-ending environmental problem caused by chemicals from agriculture, industry, mining, and trash dumping. Moreover, contaminated water may lead to various human complications and deadly illnesses. The World Health Organization revealed that cholera, diarrhea, dysentery, hepatitis A, typhoid, and polio could be linked to water contamination. The most prevalent and familiar to rural areas is schistosomiasis, an acute and chronic disease caused by parasitic worms contracted through exposure to infested water. The World Health Organization further elaborated that approximately 2.5 billion people as of the year 2015 lack safe water at home. 263 million of them spend more than 30 minutes collecting water. 159 million of the number directly consume water from lakes and streams, and 844 million of them do not have an adequate essential water drinking services. Nevertheless, water is proven to be universally critical in the context of human living. Without it, it would simply look impossible for the planet nor the humanity to sustain itself. The illustration here will show the significant impacts of consuming contaminated water on a global scale. The first graph that you are witnessing shows that unsafe water supplies have taken more lives than natural disasters and conflicts combined. The second graph is a statistics showing the risk factors of diarrhea, a very common yet deadly disease. Shown in the graph are factors that roots from having unsafe water supplies. Moreover, the experiment will mainly focus on the locality of Davao City, specifically the district of Cabantian. As a resident of the said location, Rain has stated that there exists an underlying problem of having unsafe water sources in the area. She elaborated that the water there sometimes turns muddy. Hence, this area would be the main interest of our experiment. Now, for our objectives, the group have decided to conduct an experiment that aims to counteract the problems of consuming contaminated water. Hence, we have chosen filtration as our primary experiment. Water filtration can be defined as the process of removing or reducing the concentration of particulate matter, such as suspended materials or particles, parasites, bacteria, algae, viruses, and fungi, as well as other undesirable chemical and biological contaminants from contaminated water in order to produce a safe and clean water for a specific purpose, such as drinking, medical, or pharmaceutical purposes. The following are the expected outcomes during and after conducting the experiments. First one, produce an improvised filtration apparatus purely out of household materials. The second one, produce safe and filtered water using the improvised filtration apparatus. Now let us proceed to the experiment proper. Kindly watch and enjoy the video.
The materials needed for this experiment are the following: cotton, coffee filter, 1 liter water bottle, fine and coarse sand, gravel, activated charcoal, and a container, wherein in our case we used a liquid measuring cup. Filter assembly. The first step is to cut the bottom part of the bottle. Next, cut a drain hole in the cap of the bottle. Then, put in the first layer of the filter, which is the cotton stuffing to be used as the straining fabric. Next, pour in at least 3 inches of activated charcoal as the second layer. Add 2 to 3 inches of fine sand. And 2 to 3 inches of coarse sand for the fourth layer. Then put in the gravel as the last layer of the filter. And the filter is done. Experiment time. First, test the pH level of the dirty water using the pH test strip and red litmus paper. Next, pour in the dirty water into the filter. Then, wait until filtration is over to test the filtrated water's pH level.
Here are some pictures intended for the documentation of our experiment. As seen in the video, the filter consisted of 5 layers. First, the cotton. Second, the activated charcoal. Third, the fine sand. Fourth, the coarse sand. And for the fifth layer, gravel. For our discussion, here is an illustration of our filter apparatus. For the first layer, the material that we used was cotton as our straining fabric. Cotton is the most widely used material for cloth masks perform better at higher weave densities. In other words, thread count, and can make a significant difference in filtration efficiencies. Second is the activated charcoal. It works through the process of absorption. It is the ideal water filter because it removes toxins from the water without stripping the water of salts and important minerals. For the third layer, the fine sand, it is widely used in water purification and removing suspended matter by a completely different mechanism. Instead of the water passing through small orifices through which particles cannot pass, it runs through a bed of filter medium. typically 0.75 mm sand 750 millimeters deep. Fourth layer is a coarse sand. The coarse sand functions just as the fine sand does. And for the fifth layer, gravel. Gravel is an extremely effective filter media because of its ability to hold back precipitates containing impurities. Filter sand size, angularity, and hardness are the important filter sand characteristics to ensure proper filtering. In verifying the potency of water, we used two tests with a litmus paper and pH test strip. These two tests are excellent in determining whether the water is basic or acidic. Furthermore, it also identifies the pH level of the filtered water. We utilized a household filtering apparatus to filter a sample of tap water in Cabantian, Davao City. The experiment showed that the filtered water sample in Cabantian district remained at a pH balance of 7, the pH of pure water, which indicates that it is neutral. The results show that after filtering water through 5 different mediums, namely cotton, activated charcoal, fine sand, coarse sand, and gravel, the tap water had no turbidity and is therefore safe and potable. The results verified that an improvised filtration apparatus made purely out of household materials can produce safe and filtered water. Once again, this has been Francis Camille Deloria together with Rain Abadilla and John Kyle Bungato for Pagsala, a filtration experiment on the water supply of the vicinity of Cabantian District. Thank you and have a good day.